मॅम तुमचा आवाजच येत नाहीये.
Hello, am I audible now?
Yes, ma'am.
Actually, तो हेडफोन कनेक्ट होत नव्हता दुसरा आता बदलला. It's okay. Shall we start? Actually, very less students are there. Still, I think we should start. Okay. Now, okay, chapter 3. In the last lecture, we have just started, that means just introduction we did about the chapter number 3, that is secondary treatment units. Okay. Now, in the secondary treatment units, what we are going to study: filtration, disinfection, demineralization methods, fluoridation, and defluoridation. Okay. This much part we are going to study in a chapter number 3. So the first thing we will start the filtration. Okay, so what is the theory of filtration? Okay, I will read this slide and then I will explain about the theory of filtration. The purpose of filtration is to remove the suspended particles from water by passing the water through a medium such as sand. In the last lecture, I told you those particles which are able to settle in a plain sedimentation tank, means the discrete particles, will be settled out in a plain sedimentation tank. Then to increase the efficiency of sedimentation tank, we can add the coagulants and further particles we can remove in the sedimentation tank. Still, those particles are not able to settle down with the coagulation also can be removed along with coagulation as well as tube settling or the plate settling we can use to increase the efficiency of sedimentation. Is it? So this way we are removing the suspended particles present into water. But still, in spite of that, there is some suspended particles, some quantity of dissolved particles will remain into water, and that has to be removed by using the filtration process. Now in the filtration process, there is a sand bed, simple sand bed usually. Okay, so there are multiple different types of filter media we can use that we are going to discuss further. But usually the sand is a filter media can be used. Now in that sand media, we can see, a second. Okay, so in that sand bed, you can see there are the multiple particles coming together, sand particles. Okay, and because of that, there will be a wide space. I will show you with this. So this may be the sand, 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 this may be the sand. Okay, so likewise bed you can form, and there is a void space between these two particles. Okay, and the water is moving through this. Water is percolating through this void space, and that process is known as the filtration. Now the detailed mechanism and what action exactly happens because of that, the impurities from the water are being removed, that we are going to discuss in detail. Okay, so this is the filtration. I will continue to read the slide. The purpose of filtration is to remove suspended particles from water by passing the water through a medium as a sand, such as sand. As water passes through the filter floc, and impurities get stuck in the sand and the clean water goes through. The filtered water collects in the clear well where it is disinfected and then sent to the customers. Means after filtration, what process we should go for? We should provide the disinfection treatment before sending it to the consumer. Why? Because during the filtration process, we are not taking the help of only the void space present into the sand media, but also on this sand media there will be microbial growth uh, will be observed, and that microbial growth will help us to absorb, to eat the organic impurities which are in a dissolved form in a water, that can be, which we are not able to remove by simple straining or sedimentation, by using coagulation, whatever we did until now, but that can be removed by using the microorganisms, by using the bacteria, and that growth is possible on the sand particle. Okay, and that grown microorganism will consume the organic material present into flowing water, and they become a heavier one, and then that can be settled down at the bottom. Okay, I'm going to show you the filter. Okay, trying to explain up to the extreme possible. Okay, filtration is usually, so as there we are using a bacteria, we are allowing to grow the bacteria. Definitely the water is bacterial contaminated. So after the filtration process, we must provide the disinfection process and to kill the bacteria before sending the water towards the public or the customers. Filtration is usually the final step in the solids removal process, which began with coagulation and advanced through flocculation and sedimentation. In the filter, up to 99.5% of the suspended solids in the water can be removed, including minerals, floc, and microorganisms. Okay, so these entire impurities can be removed by using the filtration. Only remain what 0.5% microorganisms or the bacterial growth will be remain present, and that can be removed by using the disinfection by applying it after the filtration. Okay, understood? So this is the filtration process. This is the theory of filtration. I hope you understood. Now we will see in a detail what is the filtration mechanism. Usually, you can assume this is a filter. Sorry. Okay, you can assume this is a filter. Okay. Then this may be the bed of filter, that is sand particles you can say, and this will be the water. Okay, here will be the water which you want to filter, and here you can find there will be the sand particles. Okay, smaller size sand particles at the top, and as it goes towards the base, the size should be increased. Okay, so likewise structure we need to design. So in that, what exactly the different mechanisms being performed through which we are achieving 99.95% removal of suspended solids using the filtration, that we are going to study. There are four basic filtration mechanisms. As I am discussing, I request everybody to note down this. Okay, there are four basic filtration mechanisms. First one is the sedimentation. What is the sedimentation? The mechanism of sedimentation is due to force of gravity and the associated settling velocity of the particle, which causes it to cross the streamlines and reach the collectors. Sedimentation process occurs. Means, as I told you, oops, I should not remove the, why I have deleted. You can see here, in this, Okay, I will show you. Ha. This is a wide shape, and because of that, tube-like structure is being formed everywhere. Everywhere, tube-like structure is being formed. Okay, are you able to see? And this tube-like structure are acting as a tube settler. These tube-like structure are acting as a tube settler. That means the sedimentation of the particles are will be settled down here at the bottom of each tube, and then during the flushing entire will be collected at the bottom. So at the bottom here you can see there will be a collection system. Here will be the collection system which is usually known as a under drainage system, which is usually known as, means whatever water is falling down, it will be collected by using this pipeline, or we can say it is an under drainage system. Okay, so that way the sedimentation action is being performed to means in a filtration, not a single action is being performed to remove the to achieve the 99.5% efficiency, but also there are four different mechanisms are working together, and these four mechanisms are helping each other to increase the efficiency of filter. So likewise, the first mechanism is the sedimentation. How the sedimentation is being performed in the filtration tank, I shown to you. Because we have used the sand particles and these are usually in a spherical form, there will be a wide space between two particles, and that void space is going to be converted into a tube-like structures at multiple places as shown in the figure, and that tube-like structure itself is acting as a tube settler, and sedimentation action is being performed. Understood? Understood everybody? Let me know, understood or not?
Yes, ma'am.
Okay. Then we'll see the next action we will see. Next action is the interception. Interception of particle is common for large particles. If a large enough particle follow the streamline that lies very close to the media surface, it will hit the media grain and be captured. Okay, so interception particles is a common for large particles. जे त्या void space पेक्षा ज्या particle ची size मोठी असेल, automatically it will be restricted over there at the surface itself. It will not be allowed to flow in the void space itself. Okay, so that process is known as the interception. Then Brownian diffusion. Brownian diffusion, what is this? Diffusion towards media granules occurs for very small particles such as viruses. Particles move randomly about within the fluid due to thermal gradients. This mechanism is only important for particles with diameters less than 1 micron. What is this? The particles move randomly about within the fluid. जितके इतके फाईन फाईन पार्टिकल्स असतात त्याला युजली कोलायडल पार्टिकल्स म्हणून आयडेंटिफाय केलं जातं. त्यांच्या कोलायडल पार्टिकलच्या मुवमेंट कशा असतात माहिती का? दे मूव लाईक दिस इन अ वॉटर continuously. They move like this in a water continuously. Then how come we can catch them? Is it possible to catch them in a plain sedimentation? Sometimes due to application of coagulation and inserting the tube settler or the plate settler in the existing design of the sedimentation tank is also not possible at all to remove such types of particles. Then how it is possible? In a sedimentation tank, actually the sand particles are acting as obstacles and neutralizing the charge of these particles. When they are strike upon the wall or the strike upon the filter media, they lose their charge and they don't become capable to move like this way. And because of that, they can be fall down in that particular region or restricted in that particular region. This is the Brownian diffusion. Then inertia. Attachment by inertia occurs when large particles move fast enough to travel off their streamlines and dumped into media grains. Attachment by inertia occurs when larger particles move faster enough to travel off their streamlines and bump into the media grains. So same action is being performed over here. When they are moving, at that time, it will not be allowed to move freely in this filter, because that filter is filled with the multiple number of sand particles, and they will not allow to free the move the particle freely in their region, and hence the particles will be removed from the water. Okay, so these different actions are helping to remove the to increase the efficiency of filter. Okay, those who have not copied, please copy. Shall we proceed, guys? Shall we proceed?
Yes, ma'am.
Okay. Now, what type of filter media we can use? We can use sand, we can use gravel, or some artificial materials like the anthracite material, plastic material. We can use as a filter media. Only thing, we should, what is the mm, final opinion in that respect, or final ultimate aim of this process? To remove the entire suspended particles from the water. Okay, just give me a 1 second, guys, please. Okay, guys, I'm back. So we this type of material we can use as a filter media. Okay, then only the concept or the criteria in respect of the filter media, it should be enough tough. Okay, it should not be getting eroded and mixing their own contaminants into water instead of removing the impurities from the water. Okay, that must be firm in the this respect. Okay, then next, types of filter. There are different types of filters available. For these types of filter we are studying for the water supply in treatment plants, not at the home. Somebody will say me why there is not mentioned the RO filter. RO filter or the reverse osmosis process is a tertiary treatment process. The water is being treated into the municipal corporation. We are treating at our home. That is the tertiary treatment process. Okay, are you getting? So in the tertiary treatment process, we can provide the reverse osmosis process. So the types, these are the types of filter we can use at the plant to treat the water. So the first one is the slow sand filter, then rapid sand filter, then multimedia filter, then pressure filter. Likewise, different filters are there. So the first slow sand filter, they consist of fine sand supported by gravel. They capture particles near the surface of the bed and are usually cleaned by scraping away the top layer of sand that contains the particles. Okay, it consists fine sand supported by gravel. They capture particles near the surface of the bed and are usually cleaned by scraping. Okay, this is the slow sand. Then rapid sand, they consist of larger sand grains supported by the gravel. and capture particles throughout the bed. They are cleaned by backwashing water through the bed to lift out the particles. You may not understand the difference between these two sentences. They, they capture particles near the surface. हीच लोसांची प्रॉपर्टी. आणि इथं काय सांगितलंय, they capture, they consist the larger grains by supported and capture particles throughout the bed. That is the first difference. Second thing, they can be cleaned by scraping away the top layer of sand. And here, they can be cleaned by backwashing through the bed to lift out the particles. Okay? So you will understand the difference better when you are going to study in detail these two types of filter. Then multimedia filter, they consist of two or more layers of the different granule materials with different densities. Usually anthracite coal, sand, gravel are used. The different layers combined may provide more versatile collection than a single sand layer. Because of the differences in densities, the layers stay neatly separated even after backwashing. So you are not knowing what is that concept backwashing, so you may be confused. But I will explain directly one to one. So the next we are going to see the first one, slow sand filter. Simply you write down types of filter, slow sand filter, rapid sand filter and multimedia filter. Don't write the details, only the titles you write down, please fast. Then we'll proceed to the next point. Written? May I proceed?
No, ma'am. What changes?
Okay, okay. Only title write down. Don't write the details.
Yes, ma'am.
Proceed.
Yes, ma'am.
Okay, thank you. So the first of all, we are going to study about the slow sand filter. So before I explain, I request you to draw the figure, because until you will not understand the one-to-one parts, you will not understand my explanation. Okay. So in detail, we are going to study that slow sand filter. Start drawing this figure as much as possible in less time. You please complete this figure. In this meeting, less than 1 minute is remain. Still, I will connect once it is getting disconnected. So you please start. You can start drawing here. I will guide you. So this is the first chamber you can draw first. So water is entering through this. It is going up and then coming to the next chamber, and here is a sand filter. That the filtered water will be collected here and it will be transported to the next chamber, and through here telescope the water will be collected out from this filter. Okay, this is the path. So you can start drawing in this direction.